Now we're going to use the rectangle model to model and illustrate how we add fractions and why we add fractions the way we do. So I'm going to start by drawing some units. I want to add 1/5 and 2/5. So to do this, I need to model each of those fractions first. So 2, 3, 4, 5. I will draw a unit to model 1/5, and then I'll draw a unit to model 2/5, and then I'll draw a unit to model the sum. So when we add fractions, we always model the two fractions in separate units, and then we have another unit to model the sum. Now I'm going to start by sketching 1/5 in the first unit. This is 1/5, and I'll sketch 2/5 in this unit. That's what I'm doing here, modeling and sketching those. So I have 1/5 and 2/5. Now if I'm going to combine those, imagine that I'm transferring those rods over to this third unit here. I would have 3 rods altogether. So I'm going to draw those in. This is the rod for my first unit, and this is the rod for my second unit. And that gives me my 3/5. So I have shaded 3 equal pieces, and the unit's been divided into 5 pieces. So that means I have shaded 3/5. So that tells me that 1/5 plus 2/5 is 3/5. Now, can you see why the rule for adding fractions is to add numerators and keep the denominator? Because we've divided each of these units into fifths, and we're just adding those pieces together. So we still have fifths. We have 3/5 altogether. Now what happens when we have different denominators? Well, we kind of have to get to the point where we have the same denominator. So I'm going to add 1/2 and 1/3. I'll start by modeling 1/2 and 1/3 separately, and then I'll model their sum. So I'm going to start by drawing a diagram that I can model 1/2 and 1/3, and I'm choosing now to do a 4x3. I could also do a 2x3 or different ones, but I'm going to show you what it looks like if it's a 4x3. There's one to model 1/2, and this is going to model 1/3, and this is going to model their sum. Notice I have the same size units. It's 1/2 of the unit, 1/3 of the unit. Now this we haven't done before, but half of this will simply be dividing it in half like this. And 1/3 of it will be like this. So I'll model 1/2, and I want to use one color here for this. And this is going to be important that you show what you're doing. I would definitely use colors. You don't have to use the colors I'm using, but definitely use colors. And then the 1/3, we can use, how about a purple maybe? That's different enough. Something that you can tell the difference. It's 1/2 and 1/3. Now imagine that I'm transferring those rods over to here. I can easily transfer one of them without any difficulty. I'll just move this 1/2 picture right over here. So there's my 1/2. It's not too bad. The next one's going to be a little harder to do because I have the 1/3 and I don't have a whole column left, and I can't overlap my 1/2. So I'm going to have to think of dividing that 1/3 into single units, and there's 4 single units, and so I'm going to color in 4 of the single units here. So one more single unit, and another one, and another one, and another one. So that's 4 of them. So if I want to write the sum, I'm going to have to divide this into equal parts. So I'll do that here by dividing this into single units. And to show what's going on, I'm going to divide all of these into single units. So I start out by actually modeling the 1/2, and then I have to, this is actually getting a common denominator at this point. Once I've broken those all up into single units, I have 12 pieces that fit all the units. And in the sum, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of the pieces modeled. So 10 twelfths is what the sum is. So you could say that 1/2 plus 1/3 is 6 twelfths. That's what I have in my first model. And then the 1/3 turned into 4 twelfths, and together it is 10 twelfths. So 12 is not the least common denominator, but it is a common denominator for 1/2 and 1/3. And this, I hope, helps you see that we have to change to common denominators because we can only add equal sized pieces. So when we do this written algorithm, we would change the 1/2 and the 1/3 to equivalent fractions that have the same denominator, and then we just add the numerators and keep the denominator.